Hello, hello, Algebra students. How are you? This is Ms. Carranza, and today we're going to talk about Lesson 8.7, Day 2. We started by talking about quadratic functions and finding their vertex if they're written in standard form. Today we're going to be graphing quadratic functions in standard form by using the vertex and its solutions. We've actually solved quadratics in the past. We solved them by factoring, we solved them by quadratic formula. So those will be your options today. If factoring doesn't work, you can always use quadratic formula, but we've already done finding solutions of quadratics. So now we're going to kind of weave it with the new lesson, mix it with the new lesson. Okay, now the solutions to a quadratic equation we would get by factoring or solving, and they would look like x equals 3, or x equals 0, or x equals a half. Okay, so solutions could look something like that, or like this. Okay, but on a graph, solutions are where the x values, where the parabola intersects the x-axis. So when you are graphing your parabola, okay, there are three things that can happen. So take a minute to draw this box with 4 columns. Pause the video if you need to. When you're ready, draw an x and a y axis in each box. Okay, there are three things that can happen when you're graphing a parabola. Your parabola might hit the x-axis twice. It can open up or it can open down. So let's say that your parabola intersects the x-axis at -1 and 2. And this parabola opens up. It could also open down. That part doesn't matter. What matters is how many times it touches the x-axis. Since it hits the x-axis at -1 and at 2, your solutions are x equals -1 and x equals 2. So if your parabola intersects or touches the x-axis twice, it's going to have 2 solutions. So that's one thing that can happen when you graph a parabola. You can have 2 solutions. Another thing that can happen is that you might only have one solution. That will occur if you draw your parabola, if you graph your parabola, and it only intersects the x-axis once. So let's say that it intersected the x-axis at -1. Now let's draw this one opening down. Again, it can open up or it can open down. But in this case, you see how it only touches one time? So the solution would only be x equals -1 because it only intersects the x-axis once. The third thing that can happen when you graph a parabola is that it has no solution, no real solution. Now, no real solution means that it does not touch the x-axis. Now, would this count as no solution because it doesn't touch the x-axis? Nope, because remember, parabolas go on forever, so ultimately this would touch the x-axis. So that would not count as no real solution. Your parabola must never touch the x-axis, ever. So something like this would count for it to be no real solution. Sorry, so your parabola must never touch the x-axis if it's going to have no real solution. Now it can also open down. It can be in any quadrant. So I could draw it in this quadrant or over here. The point is that your parabola, in order for it to have no real solution, cannot touch the x-axis. Okay? So solutions for this one would be no real solution. I want you guys to remember that when we were using the quadratic formula, we would get no real solution when we square rooted a negative. That's going to be important today. Okay, now from a graph, it's very easy to see what the solutions are, as you can tell here. Just look at where it touches the x-axis. But you don't need a graph to find the solutions. You can use factoring or quadratic formula to find the solutions. Remember to pause the video whenever you need to. Okay, number 1. Graph the quadratic functions by using the vertex and the solutions. Remember that the vertex is a two-step process. It's got an x value and a y value. To find the x value, you're going to take the opposite of b and divide it by 2 times a. That's your x value. Once you find that, you're going to substitute your x value into your equation to find the y value. The solutions will be found either by factoring or the quadratic formula. Now, some of you really never liked factoring. It's not the easiest topic. So if you'd like to use the quadratic formula every single time, go for it. It's not always the fastest, so I'll show you both ways when possible. Okay, let's take a look at number 1. Y equals x squared plus 10x plus 24. I need to graph this parabola. The first thing that I notice is that my leading coefficient is positive 1. That means that my parabola is going to open up. So I already know that it's going to look like a smiley face. Okay, now I was asked to find two things, the vertex and the solution. So I'm going to go ahead and find the vertex first. Remember, it's a two-step process. To find the x value, I'm going to take the opposite of b. So before we begin, I'm going to go ahead and label the a, b, and c. A is the leading coefficient of the x squared, so that's a 1. B is the leading coefficient of the linear term of the x, and then c is your constant term. Okay, so I'm going to take the opposite of 10, which would be negative 10, and divide it by 2 times a. Now, that's not a decimal, remember, it's 2 times a. Do the denominator first, the bottom. 2 times 1 is 2, and then divide. You get negative 5. I'm going to go ahead and substitute that into my equation to find the y value. So here's my equation. Y equals x squared plus 10x plus 24. Substitute your value of x into every x value, keeping your exponent outside of the parentheses. So now go ahead and substitute your 5. Okay, pause the video and go ahead and substitute that. Take your time. I just realized it's negative 5, and I accidentally put positive 5. Okay. Okay, I got a value of negative 1. If you did not get the same thing I did, it's possible that you didn't put parentheses and then the squared on the outside. So make sure you have a negative 5 inside the parentheses. Close the parentheses, then raise it to the power of 2, plus 10 times negative 5. Earlier I forgot to write negative 5. I just substituted 5, but it should be negative 5. Okay, and that's your vertex. Now, for the solutions, remember I told you that you have two options. You can try to factor. This was a vertex. That was the first thing they asked for. Now I'm looking for the solutions. Okay. I'm going to show you two different ways to do it. Okay. Factoring is faster for me. But like I said, it's not everyone's favorite, so I'll show you how to use the quadratic formula instead. Okay, to find the solutions, you're going to take your y value and you're going to replace it with a 0. Why? How come? Because remember what we talked about, that the solutions are where your parabola touches the x-axis. Those are called x-intercepts, and we studied those back in Chapter 3 and Chapter 2. So x-intercepts are points where the x has a value and the y doesn't. So these are ordered pairs. Think back. This would be 2 comma 0. That's an x-intercept. This would be negative 1 comma 0. So x-intercepts have a y value of 0. Therefore, the solutions, which are essentially the x-intercepts, you're going to substitute 0 for y. And then you're going to solve by factoring or quadratic formula. I'm going to try to see if this factors. I'm going to multiply a and c and find out if I can find two numbers that multiply to 24 but add to 10. Now they both have to be positive because there's no negatives in the problem. So even though I can make 10 from 2 and 12 by doing 12 minus 2, I would have to use subtraction. That's a negative. And remember, there's no negatives in the problem. So the combo that would work would be 4 and 6. I can use my shortcut and say this is x plus 4 and x plus 6. If you don't like the shortcut, you would split the middle into a 4x plus 6x. Then take the GCF of the first two terms, GCF of the second two terms, and then you would get x plus 6, which are your GCFs, and then the remainder from dividing these two by the GCF of x and these two by the GCF of 6, you should end up with x plus 4. Set each one of these equal to 0, and you get an answer of negative 6 and negative 4. So those are your solutions. Now remember, they asked us originally to find the vertex, which I did, and find the solutions. That should be enough for you to make a quick sketch of the parabola. So let me show you that you can also use the quadratic formula to solve. Y equals 1x squared plus 10x plus 24. To solve, x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Simplify it the way we were practicing. The number inside the root and then the denominator. So if you remember, I asked you to do that. And then simplify. So negative 10. Now the square root of 4 is 2, so you're going to do negative 10 plus the square root of 4. Then divide that answer by 2. You're going to do negative 10 minus square root of 4, which is just 2, divided by 2. Negative 10 plus 2 is negative 8. Negative 8 divided by 2 is negative 4. Negative 10 minus 2 is negative 12. Divided by 2 is negative 6. So notice we got the same exact answers as when we factored. And that should always happen. Now, quadratic formula is going to be an absolute must. You're going to have to use quadratic formula when factoring doesn't work. So if there were no combinations that multiplied to 24 and added to 10, that would mean that I had to use quadratic formula. Okay, to make some space, I'm going to go ahead and erase some of this so that I can make a quick sketch. Now I need to graph the vertex, which was negative 5, negative 1. Doesn't have to be perfect. You can already tell my lines are a little crooked. I'm just going 7 in each direction. So negative 5, 1, 2, 3, 4, 5. Negative 1 would be around there. And actually, I'm going to use a different color. Now remember I told you that there's an imaginary line that passes through the parabola and cuts it in half. It always goes through the vertex. So I always like to draw it because it helps me keep my parabola symmetrical. Okay, now my solutions are negative 6, so my parabola touches the x-axis at negative 6. Remember this ordered pair was negative 5, negative 1. So here's negative 6 and then negative 4. And that's all I need to graph my parabola. The solutions, negative 4 and negative 6, which are ordered pairs. So I'm going to write them as ordered pairs so you guys can see. And your vertex. So again, we practiced finding the vertex the first time we learned 8.7. So in 8.7 notes day 1, and now we're combining that with everything that we've learned with quadratic formula and factoring to find the solutions that are also ordered pairs. You can write them as ordered pairs, which are x-intercepts. Okay, when you're ready, go ahead and copy example 2. Pause the video, and I want you to find the vertex by yourself. Unpause the video when you have finished finding the vertex. No cheating. Okay, hopefully you paused the video and you didn't cheat and found the vertex on your own. Remember that practicing to do these on your own and not just copying the notes blindly is going to help you do better on tests and quizzes. I got an answer of 1, 4. If you didn't get that right, double check your signs. The original values for A, B, and C, you should have had a negative 9 and a negative 5 for A and C and a positive 18. But when you're finding the vertex, you always got to do the opposite of B. Just like in the quadratic formula, it was x equals the opposite of B. Same thing here. Okay, so I got positive 1. I substituted into my equation, and I got 4. Now, to find the solutions, I am going to try to factor. And if I can't factor, I'm going to use the quadratic formula. Okay, I'm going to do it 2 ways. I'm going to try to factor it. Do not copy this if you don't like factoring, okay? Oops. If you like quadratic formula better, I'll show you that in a little bit. Okay. Now, you start by setting it equal to 0, so replace the y with a 0. When you are factoring, I don't know if you remember this, but if the leading coefficient is negative, you want to divide everything by negative 1. So if your leader is negative, your GCF is negative. There's nothing else that these 3 numbers have in common in terms of a GCF, so the GCF is just negative 1. So if I divide everything by negative 1, I get 9x squared minus 18x plus 5. Now I'm ready to start factoring that. 9 times 5 is 45. So I'm looking for 2 numbers that multiply to 45 but add to negative 18. 1 and 45, 3 and 15. Ah! Let's do it. Negative 3 and negative 15 will work. So I'm going to go ahead and factor this. Take the GCF of the first 2. Take the GCF of the second 2. And then write down the remainder. Oops. Just bring down that negative 1. Okay. So I've got 3x minus 5 and then 3x minus 1. Okay. In terms of the graph, since this one had a leading coefficient that was negative, I knew that this parabola was going to open down. Okay, so keep that in mind. Since a Leading coefficient, your quadratic term is negative. This parabola is going to open down. Okay, I need to keep going and I need to set each of these equal to 0 and solve. So my answer is going to be, oops, I don't know why that 5 came out all kinds of crazy. My answers are 5/3 and 1/3. Now, since we're going to have to graph these, it's really important for you guys to change these into decimals so that you know where to find them. So on your calculator, do 5 divided by 3, and you should get 1.667, or 1.67. 1/3 is approximately 0.33, 0.33 repeating. To graph that, I'm going to go ahead and do the same thing that I did last time. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to plot the vertex, which is 1, 4. And then I notice that my parabola touches the x-axis. This is the axis. Oops, I just missed it by a little bit. Axis of symmetry. So I just want to make that a little bit neater. Okay. Now you don't have to draw the axis of symmetry, but I recommend you practice drawing it because it helps you keep everything symmetrical. Okay. So my other x-intercepts or x values are 167, so past the 1, past the halfway mark, and then 0.33, so that's before the 1 and before the half. And you can see it's a teeny skinny parabola. The reason it's so skinny or thin is because the leading coefficient is, if you ignore the negative, the bigger the number, so if you take the absolute value of it, so ignore the negative, the bigger the number, the skinnier the parabola is going to be. So if you look at number 1, that one was a wider parabola. It was fatter, I guess, if you want to think of it that way, because it had a 1 in front. That's not a very big number. Here, if you ignore the negative and you look, 9's a pretty big number. So again, the bigger the number, the skinnier the parabola. Okay, so you're going to get the same answers of 0.33 and 1.67 if you use the quadratic formula. So now I'm going to show you how to do that. If you already did it by factoring, you don't have to write this again. So for the quadratic formula, you're going to start by setting the y equal to 0 also. And you're going to label your a, b, and c. And then you're going to go ahead and start setting up. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Clean it up. Okay, so go ahead and find those answers on your calculator. Pause the video and pause it when you're ready and you've got them. Okay, so I got 144 and 18, and then you split it up. So you're going to do negative 18 plus square root of 144. Now, for those of you that notice, square root of 144 is just 12, so you don't have to keep writing square root of 144. You can just write 12. Negative 18 plus 12 is negative 6. Divided by negative 18 gives you 1.33, or sorry, 0.33333. So this one's going to give you this answer. Negative 18 minus 12 is negative 30, and negative 30 divided by negative 18, I forgot to put my negative there, will give you the 1.67. So you get the same answers. Now on your homework, you will be allowed to choose whatever strategy works best for you. Just be careful that if something cannot be factored, you're definitely going to have to use the quadratic formula, but you should be getting the same answer. Now, when you are graphing, my recommendation is to draw your axis of symmetry, which is that imaginary dashed line that goes right through the vertex. So as soon as you graph your vertex, draw that imaginary vertical line so you can make sure that your parabola is symmetrical. Now, you never ever want, for example, to draw a parabola, the axis of symmetry down the middle, and then have one side of your parabola be farther away. Do you see the space here? You don't want this to be farther away from the axis of symmetry than on the other side. That's bad. You want the distance to be exactly half, or sorry, exactly the same on both sides. So from the vertex, if you draw your axis of symmetry, your x-intercepts should be exactly the same distance. You see that? That's good. That's why it's called the axis of symmetry, because it cuts it in half, perfectly symmetrical. As always, if you need help, let me know or send me a message. All right, guys, have a wonderful day. I'll see you soon. Bye.